Now there are three forms of stationary points. We have the minimum point, as you can see here. We have the maximum point, and we also have the point of reflection. Okay. Now the question is, how do we go about determining the nature of each stationary point or each turning point? So the first thing we do is we are given a function of x, that's y is equals to f of x, and then we have to determine the y dx, that's f dash of x, and thereafter we evaluate the y dx equals to 0, and we solve the values of x for that instance. And in step 3, we substitute the value of x into y is equals to f of x to find the corresponding y ordinate values, and this establishes the coordinates of the stationary point. And finally, we will find d square y dx squared. Now this is to determine the nature of that turning point. If d square y dx squared is greater than 0, the point is a minimum point, and if d square y dx squared is less than 0, the point is a maximum point, and if d square y dx squared is equal to 0, the point is a point of inflection. Now we have an example here. It says we should locate the turning point on the curve and determine its nature. Now we will go through the steps one by one. The first thing to do is to determine the y dx in step 1. We're given y is equal to 3x squared minus 6x, and step 1 says we should find the y dx, and the y dx in this instance is 6x minus 6. Okay, now in step 2, it says we should let the y dx to be equal to 0 and solve for the values of x. So in step 2, we set the y dx to be equals to 0, and the y dx is 6x minus 6, which is equals to 0, and from here we evaluate the value of x. So 6x will become 6, and x will be equals to 6 over 6, which is equals to 1. Now step 3 says we should substitute the value of x into y is equals to f of x to find the corresponding y ordinate values. So step 3, we should evaluate y is equals to f of x at x is equal to the value we add here, x is equals to 1. So we call that y is equals to 3x squared minus 6x. Therefore, when x is equals to 1, then y is equals to 3 into 1 squared minus 6 into 1, and this will give us minus 3. Since the coordinates are written in terms of x comma y, therefore the coordinate of the turning point are 1, minus 3. Now with step 3 done, we go back and look at what step 4 is saying. It says find the square y dx squared. Substitute into it the values of x found in 2. So step 4, recall that the y dx, as we found, is equal to 6x minus 6. Now let's differentiate again to evaluate the square y the x squared, and the square y the x squared is equal to 6. Now let's take a look at it again. It says substitute the values into it, the values of x found in 2. Now if you look at this, the square y the x squared, you can see that there is no way we could substitute value, so we move straight again into the next point. It says if the square y the x squared is greater than 0, the point is a minimum point. If the square y the x squared is less than 0, the point is a maximum point. And if the square y the x squared is equals to 0, the point is a point of inflection. Now the square y the x squared here, okay, the square y the x squared is greater than 0 because 6 is greater than 0. Therefore the point is a minimum point. Now from this question, we have been able to locate the turning point. The turning point is 1, minus 3, and the nature is that it is a minimum point. Let's take a look at another example. Number 2. Let's take, for instance, we are given the equation of the curve of y is equals to x raised to the power 3 minus 3x plus 5. And we are asked to determine the turning point and its stationary and the nature. Now the first thing to do in step 1 is to evaluate the y dx. The y dx is equals to 3x squared minus 3. Now in step 2 is to set the y dx to be equal to 0. Therefore we are saying 3x squared minus 3 is equal to 0. Now if we solve this via quadratic formula, we will have two values of x. We will have x is equal to 1 and x is equals to minus 1. And in step 3, we are asked to evaluate the y ordinate value for each values of x. Y ordinate values for each values of x. Therefore, when x is equals to 1, my y will be equals to 1 raised to the power 3 minus 3 into 1 plus 5. And this will give me 3. And when x is equals to minus 1, y is equals to minus 1 raised to the power 3 minus 3 into minus 1 plus 5, and this will give me 7. Now with this we have gotten the two coordinates of the turning point. When x is equals to 1, y is equals to 3. So we have 1, 3. When x is equals to minus 1 and our y is equals to 7, we have minus 1, 7. So these two are the coordinates of the turning point. Now in step 4, we are asked to evaluate the square y the x squared. Now we recall that the y dx is equal to 3x squared minus 3. Therefore the square y dx squared is equals to 6x. Now for the coordinates of 1, 3. We are going to evaluate the square y dx squared at x is equals to 1. That means this is 6 into 1, and that is 6. Now we can see that this is greater than 0. And when we have greater than 0, the point is a minimum point. But when it is less than 0, it is a maximum point. So therefore, we are saying the turning point 1, 3 is a minimum point. And likewise, for the coordinates of -1, 7, and we evaluate the square y dx squared at x is equals to -1, and this is 6 into -1, which is equals to -6, and -6 is less than 0. Therefore, -1, 7 is a maximum point because the y dx is less than 0. So let's take a look again at the conditions, and from there we will solve 2 more examples on this. Now it says if the square y dx squared is greater than 0, the point is a minimum point. If the square y dx squared is less than 0, the point is a maximum point. And if the square y dx squared is equals to 0, the point is a point of reflection. Now next video we will solve more examples following these same steps.